Hey everyone, and welcome back. We're diving deep into the world of open source code LLMs today.
It's a really exciting area right now.
Oh, absolutely.
Yeah.
Especially with some of the recent advancements.
Yeah, for sure. And we've got two research papers we want to unpack today
Okay, sounds good.
that I think are particularly relevant to AI researchers and engineers out there.
Awesome. Lay it on us.
All right, so first up, we've got OpenCoder, the open cookbook for top-tier code large language models.
I love that title, the Open Cookbook.
It's a great analogy, right? It really captures what they're doing.
Yeah, tell me more.
So OpenCoder isn't just about releasing the model itself. They're really giving you the whole recipe.
Okay.
The data, the training process, the code, the whole shebang.
Wow.
It's like they're saying, here's how we made this amazing dish. Feel free to tweak it and make it your own.
Now that's what I call open source.
Exactly.
That sounds like a gold mine for the research community.
Oh, absolutely. Having this level of transparency means that you can really get under the hood, understand the design choices, and even replicate or adapt it for your own projects. It's huge for collaboration and innovation.
That's fantastic. So OpenCoder is all about empowering you to build your own top-tier code LLMs.
Yeah.
But what if you're hitting a wall with computational costs?
Yeah, that's a real challenge.
Yeah.
And that brings us to our second paper, BitNet A4.8, pushing the efficiency limit of 1-bit LLMs.
Okay, so BitNet A4.8 is tackling that head-on,
Exactly.
trying to make those 1-bit LLMs more efficient.
Yeah, without sacrificing performance.
Without sacrificing performance. That sounds pretty tricky.
It is, but they've done it in a really clever way by combining activation, sparsification, and quantization.
Okay, I'm going to need you to break those down for me.
Sure.
Let's start with sparsification. How are they making these models sparser?
So they're using a technique called Q-sparse.
Q-sparse.
Think of it like decluttering a room.
Okay.
You're keeping the essential furniture, the things you use all the time, and getting rid of the clutter.
Makes sense.
In this case, Q-sparse is selectively retaining the most important activations at 8 bits while discarding the rest.
So it's like a strategic downsizing.
Exactly.
But how do they know which activations to keep and which ones to toss?
Right. It's got to be more than just random decluttering.
Yeah.
So they actually analyze the activation patterns within the model and figure out which layers would benefit most from this sparsification process. It's a very data-driven approach.
Oh, that's really smart. So you're not just blindly making things sparse. You're doing it with purpose based on what the data is telling you.
Exactly.
Awesome. Okay, now what about quantization? What is that all about?
Okay, so imagine you have a high-resolution image, and you want to reduce the file size so it's easier to share or store.
Okay, you might compress it.
Exactly. Quantization is kind of like that for LLMs. You're reducing the number of bits used to represent the model's activations.
Gotcha. So you're essentially making the model's data footprint smaller, which obviously helps with efficiency.
Right.
But doesn't reducing the precision of the data affect the model's accuracy?
So there's always a trade-off, but the key is to find that sweet spot where you're maximizing efficiency without a significant drop in performance.
Gotcha.
BitNet A4.8 does this by using a hybrid approach. So 4-bit integer and FP4 floating point quantization for different layers, again, based on the activation characteristics.
So it's like they're really fine-tuning this process to squeeze out every bit of efficiency they can.
Yeah, exactly.
Okay, now let's dive back into OpenCoder and that whole cookbook approach.
Yeah.
What are the key ingredients they're highlighting for building a top-tier code LLM?
They emphasize 3 main ingredients: meticulous data cleaning, incorporating code-related text data, and leveraging high-quality synthetic data during the annealing and fine-tuning stages.
Okay, there's a lot to unpack there.
Yeah.
So let's take those one by one, starting with data cleaning. Why is that so crucial for code LLMs?
Right. Well, code is much more structured than natural language.
Yeah.
And if you've got messy or incorrect code in your training data, you're essentially teaching your model bad habits.
Right.
It's like giving a chef a recipe with missing ingredients or nonsensical instructions.
Garbage in, garbage out.
Exactly.
So what kind of cleaning did the OpenCoder team do?
They built this super sophisticated data processing pipeline with over 130 language-specific rules to filter out anything that wasn't up to par.
Okay.
And it's not just about tossing out bad code. They actually went a step further and transformed certain files
Oh, wow.
to fix issues instead of just discarding them.
That's impressive.
Huh.
So clean code is the first ingredient.
Yeah.
What about this code-related text data? Why is that important?
Right, so code doesn't exist in a vacuum.
Right.
Think about all the documentation, the comments, the online discussions that surround it. All of that text provides valuable context
Okay.
and helps us understand the intent behind the code.
So it's like reading the reviews before you try a new recipe.
Yeah, exactly. You want to get a sense of what to expect
Right.
and how other people have adapted it.
Exactly. So incorporating this kind of text data gives the model a much deeper understanding of how code is used
Yes.
and discussed in the real world.
It does.
Okay, last ingredient. Synthetic data. Where does that come in?
They actually use synthetic data in two key phases.
Okay.
So annealing, which is an intermediate training stage,
Mm-hmm.
and then again during supervised fine-tuning, it helps the model generalize better and handle even more complex scenarios.
Interesting. Can you give me an example of what the synthetic data looks like?
Sure, so they created what they call code textbooks.
Code textbooks.
Yeah, so these are educational snippets explaining code concepts and providing examples.
Okay.
And they also generated high-quality code snippets with corresponding test cases
Oh, very cool.
to ensure that the synthetic code is both syntactically and semantically correct.
So it's like they're giving the model extra practice problems to really sharpen its skills.
Yeah.
I'm curious, did they uncover anything interesting while they were experimenting with different data processing techniques?
They did.
Like,
So one of their key findings was the importance of deduplication.
okay.
And they discovered that file-level deduplication, which only removes duplicates within a single file,
Okay.
actually led to better performance than repository-level deduplication.
Wait, so removing less data actually resulted in a better model?
It might seem counterintuitive,
It does.
but think about it this way.
Right.
Removing duplicates at the repository level might eliminate code
Yeah.
that, while similar, is actually used in slightly different ways.
Right.
So by keeping more of those unique files,
You're preserving more data diversity,
exactly.
which ultimately makes the model more adaptable
Yes.
and robust.
Yep.
That's really interesting.
Yeah.
It's like having a spice rack with a wider variety of flavors.
I like that.
You can create more interesting and nuanced dishes that way.
For sure.
So they had another interesting finding.
They did.
That kind of challenged a common assumption.
Yeah.
They explored the impact of filtering data based on GitHub star ratings.
Right, because you would think that code from highly starred repositories
Would be considered higher quality?
Yeah, exactly.
But was that not the case?
Interestingly, no.
Really?
They found that filtering by star rating could actually reduce data diversity
Wow.
and negatively impact performance.
So even code from less popular repositories can be valuable
Yeah, it can.
for training.
Yeah.
It's a good reminder that popularity doesn't always equate to quality.
Right. It's like discovering a hidden gem of a restaurant.
Exactly.
Sometimes the best things are off the beaten path.
Love it.
LOL.
Okay, now speaking of training, the OpenCoder paper dives into some fascinating strategies,
Yeah,
particularly their approach to instruction tuning.
that's a cool approach.
Yes. To the use of two-stage process, right?
Mm.
What's the thinking behind that?
Okay, so think of it this way. Building a truly proficient code, LLM, is like training someone to be both a brilliant computer scientist and a skilled coder. Right. You wouldn't teach them those skills simultaneously.
You start with the fundamentals.
Exactly. And then build upon that foundation.
So it's like giving the model a solid education in computer science
Yeah.
before throwing it into the real world of coding.
Exactly.
What does that first stage involve?
It's all about building a strong theoretical foundation.
Okay.
So they fine-tune the model on a data set of question-answer pairs related to algorithms, data structures, and core programming concepts. It's like putting the model through Computer Science 101.
Very cool.
Yeah.
So first it learns the why behind the code,
Yeah.
the underlying principles and concepts.
Yeah.
And then the second stage, it moves on to the how,
Exactly.
the practical skills of writing and working with code.
So in the second stage, they fine-tune the model on high-quality code from GitHub.
Okay.
This exposes it to real-world examples of well-structured code and teaches it how to generate and manipulate code effectively.
So the first stage is like going to university, and the second stage is like getting an internship.
I love that analogy.
This two-stage approach results in a more well-rounded and capable model.
Yeah, for sure.
Speaking of capabilities, they did some extensive benchmarking
They did.
to see how OpenCoder stacks up against other code LLMs.
Right.
And how did it perform?
The results were impressive.
Okay.
It performed comparably to some of the leading proprietary models.
Wow.
on benchmarks like Human Evil MBPT and Big Code Bench.
So it can hold its own against the big guys.
Oh, yeah, it can. It even surpassed most previous open source models in terms of code generation, accuracy, and efficiency.
That's a big win for the open source community.
It is.
It means there's a readily available model that can compete with the big players.
What about BitNet A4.8? How did it fare in their evaluations? So they found that it achieved accuracy comparable to its 1.58-bit counterpart and even full precision Llama models on various language tasks, and all while using significantly fewer bits to represent its activations.
So they're getting similar performance with a fraction of the computational cost.
Exactly.
That's huge for making these models more practical for real-world applications.
Right, because it's all about finding that balance between performance and efficiency.
This has been an incredible deep dive so far.
It has.
We've uncovered some really fascinating insights about building and optimizing code LLMs.
For sure.
But before we move on, there's one more aspect of OpenCoder I want to touch upon.
Okay.
It's multilingual capabilities. They didn't just focus on English, right?
You're right. They incorporated data from a wide range of programming languages and tested the model's ability to understand and generate code in multiple languages.
So it's not just about building a great code LLM.
Right.
It's about building a code LLM that can be used by developers all over the world.
Exactly.
Regardless of their preferred programming language. That's fantastic.
It is. And it opens up some really interesting questions.
Oh, like what?
Like how these models represent and process different programming languages. Do they develop a universal understanding of code, or do they learn language-specific representations?
That's a great question.
These are questions that future research will need to explore.
I'm fascinated by the implications of all of this. What do you say we take a quick pause here and come back for part 2?
Sounds good.
To explore how these advancements are shaping the landscape of AI research and software development.
I'm ready when you are. All right, so welcome back.
All right, so we're back.
And ready to kind of dig into that so what factor.
Yeah, how are these advancements actually making a difference in the world of AI research and software development?
Exactly. It's one thing to understand how these models work, but the real question is how are they being used and what do they enable us to do?
Okay, so let's start with AI research. How are these open source code LLMs like OpenCoder changing the game for researchers?
Well, they're providing this unprecedented platform for understanding how these models learn and reason about code.
Interesting.
Imagine being able to dissect a model and see exactly how it processes information, how it makes decisions. That level of transparency is just invaluable.
It's like having a window into the AI's thought process. What kind of research does this enable?
Oh, all sorts. Researchers are using these models to investigate things like code comprehension, bug detection, even the generation of completely new algorithms.
That's amazing.
Yeah, it's really cool. And by having full access to the model's inner workings, we can glean insights that would have been impossible before.
So it's not just about using these models as tools, but also as subjects of study themselves.
Exactly.
Which can then fuel further advancements in the field.
Okay.
That's pretty cool. Okay, so what about the impact on software development? How are these models likely to change the way we build software?
Okay, so they have the potential to revolutionize the entire development process. Make it faster, more efficient, and more accessible.
All right.
Imagine a world where you can simply describe the functionality you want, in plain English. And the code LLM just writes the code for you.
Now that sounds like science fiction.
It does.
Is that really feasible, though?
It's becoming more realistic every day.
Really?
These models are already capable of generating complex code snippets from natural language descriptions.
Wow.
And as they continue to evolve,
we're
going to see more and more coding tasks being automated.
So that would free up developers to focus on the bigger picture.
Right.
The design, the architecture, the really creative aspects of software development.
Exactly. It would be a huge boost in productivity.
Incredible.
But it's not just about automating existing tasks.
Okay.
These models can also help us do things that were previously unimaginable.
Like what? Give me an example.
Okay, imagine a tool that can automatically translate legacy code into a modern programming language. Or one that can identify and fix security vulnerabilities in real time.
That would be amazing.
Yeah, it would. These are just a few examples of how these models are pushing the boundaries of what's possible.
It really feels like we're entering a new era of software development.
It does.
One where AI plays a much more central role. But with any new technology, there are always concerns.
Of course.
Some people worry that these advancements will lead to job losses. What are your thoughts on that?
Yeah, it's understandable that people have concerns,
Yeah.
but I believe that those fears are largely unfounded.
Yeah.
Yes, some jobs will inevitably change,
Right.
but history has shown that technological advancements tend to create more jobs than they destroy.
So it's not about replacing human developers,
No.
but rather about changing the nature of their work.
Precisely. Instead of focusing on the tedious and repetitive tasks,
Uh,
developers can move towards higher-level problem-solving and design thinking.
okay.
We'll need people who can understand the nuances of these models, who can guide and refine their outputs,
Right.
and who can ensure that they're being used ethically and responsibly.
So it's about collaboration between humans and AI, each leveraging their unique strengths. That makes a lot of sense.
Yeah.
Now let's talk about the models themselves. We've discussed OpenCoder's commitment to transparency and its impressive performance, but BitNet A4.8 takes a different approach, focusing on efficiency through sparsity and quantization. Can you walk us through those concepts again?
Sure. So remember our decluttering analogy for sparsification.
Yeah.
BitNet A4.8 takes that idea and applies it to the model itself.
Okay.
It selectively prunes away less important connections,
Got it.
making the model leaner and faster.
So it's not just about reducing the number of bits used.
Right.
It's about making the model itself more compact and efficient.
Right.
What about quantization? How does that work?
So quantization is like converting a high-resolution image to a lower resolution.
Okay.
You lose some detail,
Okay.
but the file size shrinks dramatically, making it faster to load and share.
Mm.
Similarly, quantization reduces the number of bits used to represent the model's weights and activations,
Okay.
resulting in smaller models and faster computations.
So they're basically finding clever ways to shrink the model's data footprint
Exactly.
without sacrificing too much performance. That's really impressive. Now, I know that training these highly efficient models can be challenging.
Yeah, it can be.
Do they have to develop any special techniques for BitNet A4.8?
Absolutely. So one of the key challenges is dealing with the non-differentiable nature of
Right.
quantization and sparsification during training.
Right.
To overcome this, they employed a technique called the straight-through estimator.
The straight-through estimator.
Think of it like a clever mathematical workaround
Okay.
that allows you to train models even with these non-differentiable operations.
It's like building a bridge over a gap in the mathematical landscape,
Exactly.
enabling the training process to continue smoothly.
And the results speak for themselves.
Yeah.
BitNet A4.8 achieves impressive performance while being significantly more efficient.
That's great.
It's a testament to the ingenuity of the researchers and the exciting possibilities of this field.
This has been such an insightful discussion. We've covered a lot of ground. From the open source nature of OpenCoder to the efficiency breakthroughs of BitNet A4.8. But there's one more thing I want to touch upon before we move on.
Okay.
The meticulous data preparation process that both teams emphasized. Can you elaborate on that a bit more?
Certainly. So both OpenCoder and BitNet A4.8 highlighted the importance of high-quality data.
Yeah.
OpenCoder in particular went to great lengths
Right.
to create a clean and diverse data set with those over 130 language-specific roles we talked about earlier.
It's all about giving the models the best possible ingredients to learn from.
Exactly.
But they didn't stop there. They also incorporated code-related text data into their training process. Why was that important?
Okay, so imagine you're learning a new language.
Okay.
You wouldn't just memorize a dictionary, right?
Yeah.
You'd immerse yourself in the culture.
Yeah.
Read books, watch movies, have conversations.
Right, to really understand it.
It's about understanding the context and nuances of the language.
So it's like giving the model a cultural immersion experience in the world of code.
Exactly.
By incorporating documentation comments and online discussions,
Yeah.
they're providing the model with a richer understanding of how code is actually used
Yes.
and understood by humans.
For sure.
That's so smart.
Yeah.
And then there's the use of synthetic data, which seems to be a growing trend in the field. What are your thoughts on that?
So synthetic data can be a powerful tool for addressing specific challenges
Okay.
and filling gaps in real-world data.
Makes sense.
OpenCoder, for example, used synthetic data to create those code textbooks and high-quality code snippets with corresponding test cases.
Right.
This helps ensure that the model is exposed to a wide range of scenarios and can generalize effectively.
It's like giving the model a personalized training regimen tailored to its specific needs.
Precisely.
And as the field of synthetic data generation continues to advance, I believe it will play an increasingly important role in training even more powerful and versatile code LLMs. This is all incredibly fascinating. We've discussed the technical aspects, the potential applications, even touched upon some of the societal implications.
Hmm.
What do you think the future holds for this field? What are you most excited about?
Ah, it's a thrilling time to be working in this space.
I bet it is.
I believe these advancements have the potential to truly democratize access to AI-powered tools,
Yeah,
enabling individuals and small teams to achieve things that were previously only possible for large organizations.
that's a really inspiring vision.
Yeah.
I'm also excited to see how these models will evolve in terms of their capabilities. Imagine a world where we can interact with computers using natural language as easily as we communicate with each other.
That's a future I'm looking forward to as well. It would break down barriers and empower anyone to harness the power of technology.
Yeah, absolutely.
But as we continue to push the boundaries, it's crucial that we do so responsibly and ethically.
Absolutely. We need to be mindful of the potential risks and ensure that these technologies are used for good, not for harm. And that brings us to the final part of our deep dive. I'm eager to explore those broader societal implications and discuss the future of this rapidly evolving field. Are you ready to wrap things up?
Absolutely. Let's delve into the big picture.
Welcome back, everyone. We're in the final act of our deep dive into open source code LLMs. We've explored how they work, what they can do, and even some concerns. But now it's time to step back and think big picture. How are these advancements shaping the future, not just of software, but of society as a whole?
It's a big question and one a lot of people are thinking about for good reason. These are powerful technologies with the potential for widespread impact. One thing I find fascinating is how open source code LLMs are changing the tech industry itself. For so long, the cutting edge of AI has been dominated by a few big companies with huge resources.
Yeah, it's been kind of a walled garden.
Huh.
Only those with the right connections or a lot of money could get in.
Exactly, but open source is changing that. It's like throwing the doors open and saying, come on in, everyone, let's explore this together.
And that shift has huge implications. Imagine startups and independent researchers having access to the same powerful AI tools as the tech giants. It levels the playing field and opens up so many opportunities for innovation.
Absolutely, it could spark a wave of creativity and new ideas from all over the world. We might see solutions to problems we haven't even imagined yet, thanks to this access to powerful AI.
It's like the early days of the internet, a whole new world of possibilities waiting to be explored. And it's not just about software. Think about the impact on scientific research. Open source code LLMs could speed up breakthroughs in fields like medicine materials, science, even climate change.
Imagine researchers being able to easily analyze huge data sets to spot patterns and come up with hypotheses that would take humans years to discover. These models could become essential tools for scientific discovery.
It's like giving every scientist a superpowered research assistant who can crunch numbers and see connections in a flash. And the benefits go way beyond the lab. These advancements could change our everyday lives in profound ways.
Think about how we use technology now. It often feels awkward and difficult. But what if we could talk to computers using everyday language, just like we talk to each other?
Right now, we have to learn their language, the language of code. But what if they could learn ours? It would make technology so much easier and more intuitive for everyone.
It would truly open up access to information and empower people who might not have the technical skills to navigate traditional computers.
It's like breaking down the language barrier between humans and machines. And the possibilities are endless. Imagine saying to your computer, hey, help me plan a trip to Italy, or write a poem about the beauty of nature, and it actually gets what you're asking and does it.
We could hand over so many everyday tasks to these AI assistants, freeing up our time and energy to focus on the things that really matter, like creativity, relationships, personal growth.
It's an exciting vision of the future, one where technology fits seamlessly into our lives and helps us achieve more. But of course, with any powerful new technology, there are concerns. Some people worry about AI taking jobs and replacing human roles. What do you think about that?
It's a valid concern and one we should definitely consider. But I believe that AI will ultimately enhance human capabilities, not replace them entirely. Just like the invention of the car didn't get rid of the need for transportation workers, AI will simply change the types of jobs we do.
So it's not about humans versus machines, but about finding ways for humans and machines to work together using each other's strengths.
Exactly. We'll need people who can design and train these models, who can understand their results and make sure they're being used ethically and responsibly. These are crucial roles that require uniquely human skills like creativity, empathy, and judgment.
And as these technologies keep evolving, those human skills will become even more important. It's not just about writing code anymore. It's about understanding the bigger picture, the impact on people, and the ethical questions.
It's a shift from being a code writer to being a code conductor guiding the AI orchestra to create beautiful and useful software that benefits everyone.
That's a great analogy.
Yeah.
It really gets at the heart of this new way of thinking.
Yeah.
It's not about handing over control to the machines, but about finding ways to work with them to create something better than either of us could alone.
And as we go forward, it's crucial to keep these ethical considerations in mind. We need to make sure these technologies are used to create a fairer and more just world where everyone benefits from the progress we're making.
I think that's a great place to wrap up. This has been an amazing journey exploring open source code LLMs. We've seen how these advances are not just changing how we write code, but also how we think about the future of work technology's role in society and our relationship with artificial intelligence.
It's been fantastic to explore this with you. And to everyone listening, stay curious, keep exploring, and join these important conversations about the future we're building together.
Thank you for joining us on this deep dive. Be sure to check the show notes for links to the research papers and resources we talked about today. Until next time, keep learning, keep innovating, and keep coding.